Okay, so for this review, we'll start with problem number 1. The ozone level in parts per billion on a summer day in a certain metropolitan area is given by P of T is equal to 20 plus 8T minus T squared, where T is the time in hours and T equals 0 corresponds to 9 a.m. Now there are two parts to this. One, you want to use the four-step procedure to find P prime of T, and then part B is to find P of 3 and P prime of 3. All right, so let's start with the four-step procedure or the four-step process for derivatives. All right, the first step is to do P of T plus H. Now, this is in terms of T, so we do P of T plus H first. So everywhere there's a T, we substitute it with T plus H. So this will be 20 plus 8 times, replace the T with T plus H, minus, our T again would be replaced with T plus H, and that will be squared. And then we just simplify this. So this will be 20 plus, distribute the 8 over the T plus H, you'll get 8T plus 8H, then minus. Now for the T plus H quantity squared, if you want to, do this off to the side and write T plus H twice, because T plus H is used as a factor twice. And then use the FOIL method. So here T times T, T squared, outer, T times H. I'm going to put the H in front of the T first. And then this other one, H times T, will be also HT plus H times H, H squared. And notice I have two HTs here, so it'll be T squared plus 2 HT plus H squared. So that's what T plus H quantity squared would be. And I'm putting this in parentheses, T squared plus 2 HT plus H squared. And then that minus sign will change the sign of every single term inside the parentheses. So this will be 20 plus 8T plus 8H minus T squared minus 2HT and then minus H squared. And I'll go no further than that. So that's what P of T plus H will be. Okay, so that's step number 1. Now step number 2 is subtracting P of T plus H minus what P of T is. So I'll take this expression, as long as it is, and then we're going to subtract from it what P of T is. P of T is that 20 plus 8T minus T squared. I'm going to bring all of this down. Now again, the minus sign makes the 20, minus 20. Minus sign makes the 8T minus 8T. And the minus sign makes the minus T squared a plus T squared. And then we simplify this. All terms that do not have an H in it, all terms that do not have an H in it should be eliminated. Like this 20 and minus 20, that's gone. Let's see, 8T and a minus 8T, that's gone. Minus T squared and plus T squared, that's gone. You should only be left with terms that have an H in them. So this will simplify as 8H minus 2ht minus h squared. So that's step 2. Then step 3 is taking that previous answer, divide that by h. So here we got 8h minus 2ht minus h squared. All that will be divided by h. And then we factor out the h, okay? Every term should have an h in it, so we factor out the h. So 8h divided by h will just be 8, minus 2ht divided by h will be 2t, minus h squared divided by h will be h. All that's divided by h. And as you can see here, these h's divide out. You'll be left with just 8 minus 2t minus h. And then the final step would just be to take the limit as h approaches 0 of p t plus h minus p of t divided by h. So the limit as h approaches 0 of 8 minus 2t minus h. Well, this h will go to 0 as we let h approach 0. So you'll be left with 8 minus 2t. Okay. And that's that 4-step procedure for finding, of course, a derivative, which we talked about back in section 2.4. And you only have one of these, okay? Because everything after that would just be using those, easy methods of finding derivatives. All right, so this represents part A. Now part B asks for P of 3 and P prime of 3. Okay. Wait, does everyone have this? Okay. So P of 3, we use that original function P of t and just substitute each t with the 3. So it'll be 20 plus 8 times t, which is 3, minus t, which is also 3, and then that's squared. So I have 20 plus 8 times 3 is 24, minus 3 squared is 9. And what's 20 plus 24 minus 9? Yeah, 35. All right, so P of 3 would be 35. And then for P prime of 3, well, P prime of t is this right here, that 8 minus 2t. So let's just use that and substitute that t with 3. So we got 8 minus 2 times 3. Well, what's 8 minus 6? 2. Because 2 times 3, that's 6. 8 minus 6 will give you 2. So the value of P prime when t is 3 would be 2. And that's all there is to it for problem number 1. Okay. Are there any questions? Okay, problem number 2 is this. Find the derivative, or dy dx, for y is equal to x to the 10th. Okay, so in this case here, we got y equal x to the 10th. All we need is just dy dx. So here we use the power rule for exponents here. I mean the power rule for derivatives. So what would be the derivative of y to the 10th? X to the 10.
10x.
10x to the ninth. We bring the power down, which is your 10. Copy the x over to the 1 less power. So it'll be 10x to the ninth. Okay. Questions on problem number 2? And number 3, we got y is equal to x to the negative 9. So now we got negative exponents here, and we want dy dx for that. So what's the derivative of x to the negative 9?
Negative 9x to the negative 10.
Right. Again, we bring the power in front, negative 9, copy the x over to the 1 less power. Negative 9 minus 1 would be negative 10. Okay. All right, number 4, g prime of x. We're finding g prime of x, but g of x is given as x to the 4/5. So here I want g prime of x. What would that be?
4/5 x to the negative 9.
Mm-mm.
Or, wait,
It's to the 1 less, negative
-1/5.
1/5, because you got to do 4/5 minus 1. And if you need to, you can do this in the calculator by doing, let's say, clear this out, 4 divided by 5, and then minus 1. Hit the math key, and then number 1. That'll give you the negative 1/5. So you have 4/5 x to the negative 1/5. Okay, questions on number 4. Let's see, number 5, here we got a polynomial function. Let's say f of t is equal to negative 5t squared minus 4t plus 2. And we want f prime of t. F prime of t. So what would this be?
Negative 10t minus 4.
Negative 10t minus 4. Bring this 2 down, multiply by the negative 5, you get negative 10. Copy the t over to the 1 less power, so it'll be t to the 1 or just t. Derivative of minus 4t would just be minus 4. And the derivative of 2, which is a constant, is 0. Are there any questions about number 5? All right, number 6. We want h prime of t if h of t is equal to 5 over t to the 1/2 minus 6 over t to the 2/3. All right, let's pull these variables out of the denominator. Write this using negative exponents, and then we can find out what h prime of t is. If I pull the t out of the denominator, it'll be t to what power? Negative 1/2. Then minus 6 times, pull the t out of this denominator, that 2/3 becomes negative 2/3. And then we're going to be doing h prime of t. So what's the derivative of 5t to the negative 1/2? What would that be?
Negative 5 over 2 x to the negative 3/2.
Yeah. Or t to,
sorry,
okay, t to the negative 3 halves. I know what you're saying. And then for minus 6, t to the negative 2/3. What would that derivative be?
plus 4 t to the negative 5/3.
Yeah. Now, if you want to, you can leave it like this, or we can pull these back in the denominator and make them positive exponents. So here you got negative 5 in the numerator. The 2 is in the denominator, but when I take that t to the negative 3 halves, back in the denominator it'll be positive 3 halves, plus 4 is in the numerator. That t will go in the denominator as t to the 5/3. Okay. So these are the two options. These are the two ways you could either leave it like this or this. Okay. Questions about number 6? Okay, number 7 is, and I'm gonna have to do this on the next page. Oh. Anybody need it? Okay. Okay. All right, now number 7. Okay, there are 4 parts to this one. So here we got f of x is equal to 3x to the 4th minus 8x cubed plus 4. F of x is equal to 3x to the 4th minus 8x cubed plus 4. Here we're going to find the following. Starting with, in part A, what f prime of x will be. So what is f prime of x?
12x to the 3rd minus 16x.
Is it 16?
Minus 24.
Minus 24.
Oh, I thought it was 8x squared. That's what I had.
Okay. So it's 24x to what power?
Squared.
Squared. And the derivative of 4 is 0. So that would be your derivative. That's part A. Part B, they want the slope of the graph of the function at x is equal to 3. So that's actually finding the slope of the tangent line at x equals 3, because that first derivative represents the slope of the tangent line. This is at x is equal to 3. So we take that first derivative, substitute each x with 3. Now, of course, you can use a calculator if you like. Let's see, 12, and then left parentheses 3, close parentheses, the hat key, and then cube. And then minus 24, left parentheses 3, close parentheses, and square it. And then hit enter. And you'll end up getting a number of 108. So that 108 represents the slope of the tangent line at x equals 3. Okay. Questions about part B? Now, part C, they ask for the equation of the tangent line at x equals 3. All right. Well, I know my x-coordinate of that ordered pair is 3. But of course, to get the y-coordinate, so at x equals 3, I need to find out what that is by just substituting each x in the original function with 3. So it'll be f of 3 equaling to 3 times 3 to the 4th minus 8 times 3 cube plus 4. So I got 3 left parentheses 3 raised to the 4th minus 8 left parentheses 3 close parentheses, 3, then 3, 4, use my right arrow to get out of it, and then minus 8, and then 3, this to the 3rd, plus 4. Now here I get 31. So my ordered pair would be 3, comma 31. And I'm going to be using, with that, the slope of the tangent line, which I found that out to be 108. And I'm going to use that in my point slope form. And the point slope form, of course, will be y minus y1 is equal to the slope times the quantity x minus x1. So it'd be y minus, here y1 would be 31, is equal to the slope of that tangent line, that's 108, times x minus x1, which is 3. Okay, if I simplify the right side, I have y minus 31 is equal to 108 times x is 108x, minus 108 times 3 would be 324. And then to get y by itself, I add 31 to both sides. So that means y is equal to 108x minus 324 plus 31 would be a minus 293. So this represents the slope of the tangent, the equation of the line at x is equal to 3. Or the equation of the tangent line when x is equal to 3. Because you have to first find out what your y-coordinate is by substituting your x in the original function, and then use that slope of the tangent line with that ordered pair. Any questions about part C? And part D looks like this. The value of x where the tangent line is horizontal. That means that our slope has to be 0. In other words, f prime of x, which is of course represents the equation or the slope of the tangent line, must be equal to 0. Well, if you go back to part A, we found out that f prime of x was 12x cubed minus 24x squared, and we're going to set that equal to 0. Now, what can we factor out in 24x cubed and 24x squared?
12x squared.
12x squared. So if I factor out the 12x squared from that 12x cubed, I have x minus, factor out the 12x squared, out of that 24x squared, it'll be, not 3, be 2. Because 24 divided by 12 will give me 2. So it'll be x minus 2 times that 12x squared is equal to 0. And then we set each factor equal to 0. So I'm going to set 12x squared to be equal to 0. And then x minus 2 will be set equal to 0. And then we solve each equation for x. So if I divide both sides by 12, that means x squared is equal to 0. And, of course, the only number squared that would give me 0 is 0. And then for the x minus 2 equal to 0, if I add 2, you'll get x is equal to 2. So, the only values of x where the tangent line would be horizontal will be at x equals 0 and at x is equal to 2. Okay? Because at those two x values, I will get a horizontal tangent. Okay. Are there any questions about problem 7? All right, problem number 8 reads this. Just finding the indicated derivative with respect to x of 11x plus 31 divided by x. What I'm going to do here is just simplify what's inside the parentheses here. I'm going to write this as 11x divided by x, and then 31 will be divided by x, because here I only got like a single term in the denominator, so this term will be divided by x, and that term will be divided by x. Well, 11x divided by x will leave me with 11. That x is like x to the first power. I'm going to pull that out of the denominator and write this as 31 x to the negative 1. And then take its derivative here. The derivative of 11 is what? 0. The derivative of 31x to the negative 1 would be?
Negative 31x to the negative 2.
Right. And then we'll write this using positive exponents here. So it'll be negative 31 divided by x squared. Pull the x back in the denominator, that negative 2 changes to positive 2. All right, questions on problem 8. All right, problem number 9. Now here we're using differentials. It just says find dy for y is equal to 35 plus 8x squared minus x cubed. Okay, so here we got y is equal to 35 plus 8x squared minus x cubed. Okay, so it's going to be dy times whatever the derivative of that is, and then we add on the dx on the end. So the derivative of 35 will be 0. The derivative of x squared will be
16.
and then minus the derivative of x cubed minus 3x squared. All of this will be in parentheses, and then we include dx. That's all there is to it. That's all they ask for. So on the exam, it'll just tell you use differentials to find dy, and this is how you would do that. Okay, questions on problem number 9. All right, number 10. For y is equal to f of x, which is equal to x to the 4th minus 7x cubed plus 3, we want to find dy and delta y given that x is equal to 5 and delta x is equal to negative 0.2. I'm just going to write it like this. Y is equal to x to the 4th minus 7x cubed plus 3. And we're told that x is equal to 5, delta x, negative 0.2. Well, let's find out what dy is first. The derivative of x to the 4th minus 7x cubed plus 3 would be what?
4x to the 3rd
Okay,
minus 21x squared.
okay. All right. Now, and I need to include something, dx. And they also want us to find delta y. Well, delta y, of course, will be f of x plus delta x minus f of x. Okay, So you might need to look back in on that section on differentials. I think it was section 2.5, I believe, or 2.6, I'm not sure. I think it was 2.6. So delta y would be f of, in this case, our x is 5, plus negative 0.2, which is delta x, minus f of 5. Now, 5 plus a negative 0.2 would be 4.8. So I got f of 4.8 minus f of 5. So that f of 4.8 would just substitute each x with the 4.8. I guess I have to do this down here. That would be 4.8 to the fourth minus 7 times 4.8 cubed plus 3. And that can be typed into the calculator. So that parentheses 4.8, close parentheses, that's going to be to the fourth, minus 7, left parentheses 4.8, close parentheses, raised to the third, plus 3. And here I get negative 240.3024. And then minus f of 5. And f of 5 is going to be this 5 to the fourth minus 7 times 5 cubed plus 3. So 5 raised to the fourth minus 7 times 5 raised to the third plus 3. And that's going to be negative 247. So this will be minus a negative 247. And this will tell me what delta y will be. So negative 240.3024 minus negative 247. So delta y would be a negative 6.6976. Okay. So that's negative 6.6976 for delta y. And they also want dy as well. So let me go back to where this is. That change in x is negative 0.2. That's also dx. Delta y and dx, delta x and dx are the same. So delta x will be dx, which is negative 0.2. I'll just substitute the x with 5. And dx with negative 0.2. Let me simplify what's inside this first parentheses here. Let's see, 4 times 5, and that's cubed, minus 21 times 5, and that's squared. That's negative 25. Times negative 0.2. That's going to end up being 5 for dy. So dy will be 5. Delta y will be negative 6.6976. Those are the two values that they're looking for. Okay. Any questions on problem number 10? Question.
So where did you get the 5 that you plug in?
X was given to me as 5. That was already given in the problem. Any other questions? Okay, number 11. And does everyone have this? All right, an egg of a particular bird is very nearly spherical. The radius to the inside of the shell is 9 millimeters, and the radius to the outside of the shell is 9.4 millimeters. Use differentials to approximate the volume of the shell. And you're told that the volume with respect to r is going to be 4/3 pi times the radius cubed, where r is the radius. Okay, so in this case, here's our formula for the volume. Now, of course, the change in R or delta R is coming from the inside. It was 9 millimeters. The outside was 9.4 millimeters. So 9.4 minus 9 would be how much? 0.4. That would be what delta R would be. Or we can say dr is 0.4, since delta R and dr pretty much mean the same. Okay. Now here, v prime of r, let's find its derivative. That constant is 4/3 pi. What's the derivative of r cubed?
3r squared.
Right. And then if I simplify this a bit, those 3's divide out, you're left with 4 pi r squared. All right, and in this case here, my dv, the derivative of the volume, would be what v prime of r is times dr. So dv will be this, 4 pi r squared dr. And then we just do substitution here. Be 4 pi times the radius. The radius was given to be 9, and that's squared. dr will be 0.4. And that can be typed in the calculator. 4 times, and then for the pi we do second and hat, because right above the hat key is the pi, times 9, and that's squared, times 0.4. And let's say I want this to 2 decimal places. So it'd be 407.15. Okay. And on the exam, I'll tell you how many places to round your final answer to. So the 2 decimal places will be 407.15 for dV. In other words, what they were asking for was the approximate volume of the shell. Any questions about problem number 11?
I have a question. Would you want like the units at the end too on the answer, or?
You can leave it like this. I think volume is probably, let's see, what was it? Cubic, yeah, cubic millimeters. Okay. Any other questions? All right, number 12. Finding the marginal, I can put this up here. Find the marginal profit function if the cost and revenue are given by C of x is equal to 159 plus 0.7x, and R of x is equal to 5x minus 0.01 x squared. Now they say marginal profit function. Now, what that means here is this. If they want the marginal profit function, they're talking about this. P prime of x, anything marginal means you have to take the derivative. And that's equal to R of x, that's the revenue, minus the cost. Or better yet, here's what I would do. Let's find the profit function first, and then take its derivative, without taking the derivative of the revenue and the cost. Let's just do that. My revenue function was 4x, no, it was 5x in problem number 12. It was 5x minus 0.01 x squared minus the cost was 159 plus 0.7 x. Notice that's in parentheses, okay? Revenue minus the cost. That's the revenue minus the entire cost function. Let me bring this down and distribute the negative over the 159 plus 0.7x. So it'll be minus 159 minus 0.7x. And I'm going to put that negative 0.01x squared in front. And then 5x minus 0.7x is how much? Anyone? 5x minus 0.7x.
4.3x.
Yeah, plus 4.3x. And then I'll bring down the minus 159. And then we can find the marginal profit function by taking the derivative of that profit function. So P prime of x will be this. What's the derivative of negative 0.1x squared?
Negative 0.02
Mm-hmm.
x.
Okay, and then plus the derivative of 4.3x will be 4.3. And that's all we need right there. So in this case, the marginal profit function, you have to do revenue minus cost first, and then whatever you get for that, you'll take its derivative. Any questions on number 12? Number 13 is finding the average cost function if the cost and revenue are given by C of x is equal to 141.63x and R of x is equal to 4x minus 0.09x. Now it says average cost function. That means the only thing we need to be dealing with is just this cost function that's given to us, not the revenue. So in this case here, my cost function C of x was 141 plus 6.3x. So if I want the average cost function, the average would be C bar of x. And the way we do that, we divide every single term in this cost function by x. So 141 would be divided by x, and 6.3 will be divided by x. So here I'll have 141 over x plus 6.3x divided by x will be 6.3. And that would be my average cost function here. 141 divided by x plus 6.3. Are there any questions about problem number 13? All right, number 14. has three parts. The cost in dollars of manufacturing X auto body frames is C of X is equal to 40,000 plus 800X. And in part A, you're to find the average cost per unit if 250 frames are produced. And it does say average cost per unit. So if C of X is equal to 40,000 plus 800X, then C bar of X, which is represented by the average cost per unit, we divide every term by X. So it'll be 40,000 divided by X plus 800X divided by X. So that means I'm going to have 40,000 over X plus 800X divided by X is just 800. Now I'm going to use that to find out the average cost per unit if 250 units are sold. So C bar 250, take this, replace the X with 250. So it'll be 40,000 divided by X, which is 250, plus 800. Then you should get 960. So that means that the average cost per unit if 250 frames are produced would be $960. And that's part A. Now part B is the marginal average cost at a production level of 250 units. Well, it does say marginal, so that means I need to take the derivative of my average cost function, which is C bar of X. That's the 40,000 divided by X plus 800. And I'm going to write that using negative exponents as 40,000 X to the negative 1 plus 800. So C bar prime of X, and it would be best to move this up. So C bar of X, what's the derivative of 40,000 X to the negative 1?
Negative 40,000 over X squared.
Okay. So that's C bar of X. So now if 250 units are sold at the production of 250 units, my average cost at 250 would be this negative 40,000 divided by 250, and that's squared. So 40,000, well, I should say negative 40,000 divided by 250, and then X squared to square it. And here I get a negative 0.64. Okay, so that's part B. So the marginal average cost would be a negative 64 cents. Now, part C is on the next page. Use the results from parts A and B to estimate the average cost per frame if 251 frames are sold. So the way we do that would be the average cost for the 251st frame would be this. If 251 frames are sold, that's one additional item. That's going to be what I got in part A, that's a C bar of 250, plus C bar prime of 250. In other words, C bar was 960. Plus C bar prime of 250 was negative 0.64. If I add those two, what would I get?
959.36.
Right. So the cost, or the average cost per frame, if 251 frames are produced, that's one additional frame, that would be $959.36. Okay. Are there any questions about problem number 14? All right, problem number 15. Okay, it's just a use of the calculator to evaluate A if to the nearest cent if A is equal to 14,000 e to the 0.04 t for t is equal to 7. So I got A is equal to 14,000 times e to the 0.04 t, and t is equal to 7. So all you do there is just do direct substitution and use your calculator to come up with your final answer. So A is equal to 14,000 e to the 0.04 times t, which is 7. So it'll be 14,000. For the E will be second ln, and then 0.04 times 7. Now the two decimal places, what would that answer be?
2082.
Okay.
18,523.8.
Okay. So that would be the amount of, let's say, a $14,000 investment at 4% compounded continuously after 7 years. Okay. Questions on problem number 15? Okay, problem 16. Let's say, recently a certain bank offered a 10-year CD that earns 2.81% compounded continuously. Let's say if $10,000 was invested in this CD. How long will it take for the account to be worth $35,000? Well, if it's going to be continuous compounding, that means we must use that continuous compounding formula. A is equal to P times E to the RT. And we're investing $10,000 in this CD, so that means our principal, which is P, that's $10,000. Interest rate is 2.81%. Now, what's 2.81% as a decimal? 0.0281. T is what we're trying to find. And the amount will be $35,000. I'll add that. So we just substitute into this continuous compounding formula. Sometimes I make it just sit. So here your A is $35,000. That's equal to P, which is 10,000, times E to the R, that's going to be 0.0281 times T. And now to get that exponential expression by itself, that E to the 0.0281 T, I need to get that by itself by dividing both sides by 10,000. So here I have e to the 0.0281t. 35,000 divided by 10,000 would be 3.5. And because E and Ln are inverses of each other, I would take the natural log on both sides of this equation. Now, Ln of e to whatever my exponent is will be that exponent. So Ln of e to the 0.0281t will be 0.0281t. And I'll bring over Ln of 3.5. And then to solve for t, I'll divide both sides by 0.0281. And in this case, I'm going to round t to 1 decimal place. So press the Ln key and then 3.5, close parentheses, divided by 0.0281. So to 1 decimal place, what would this be? 44.6 years, since time is in years. So it's going to take 44.6 years for a $10,000 investment of this CD to reach $35,000 at 2.81% compounding continuously. All right, questions about problem number 16. All right, problem number 17. It's just finding the derivatives here. 17 and 18, 19 and 20 are just derivatives. So in 17, we just need the derivative of this. We got the function f of x is equal to negative 8 plus 3x plus 3e to the x. And these are just exponential and logarithmic functions here that we're finding derivatives of. So for this, what would f prime of x be?
3 plus 3x dx.
Just the 3x is 3, but for 3e to the x, we bring down the 3, but what's the derivative of e to the x? Same thing, e to the x. That's all there is to it.
Which one is it that gives you like x dx? Yeah. We've had some before that.
That's something like the product rule. X times e to the x.
Okay.
Yeah, you have to use the product rule on that one. All right, questions on problem number 17. And I'll do 18 over here on the right side, where you got f of x is equal to 12, well, negative 12, ln of x, plus 13x squared minus 2. So what would be, let's take each term, take its derivative. What's the derivative of negative 12 ln of x? All right, negative 12 over x, because if you remember, the derivative of ln of x will be 1 over x. So if you multiply that by negative 12, you'll get negative 12 ln of x. What about the derivative of 13x squared? 26x. Derivative of a minus 2 is 0. Okay. Any questions about 18? Number 19 is the use of the product rule. And in this case here we got y is equal to 2x squared plus 3 times 4x minus 5. And he'll want the derivative of that using the product rule. If you want to, you can do this. Let that 2x minus 3 be the first, and then 4x minus 5 be the second. So the first would be 2x squared plus 3 and the second will be 4x minus 5. And in this case here, what would f prime of x, what would be the derivative of the first? 4x. And for the second being 4x minus 5, what's the derivative of the second? Just 4. And of course, I'll use dy dx. Or you can use y prime, it doesn't matter. And in this case here, it would be, using the product rule, it would be first times the derivative of the second. That's the 2x squared plus 3 times the derivative of the second, that's 4, plus the second, that's 4x minus 5, times the derivative of the first, that was 4x. And then distribute and combine like terms. So here, distribute the 4 over the 2x squared plus 3. This will be 8x squared plus 12. And then distribute the 4x over the 4x minus 5. 4x times 4x is 16x squared. Minus 5 times 4x is 20x. Combine like terms here. 8x squared and 16x squared will be 24x squared. Then I'm going to pull down that minus 20 and then plus 12. And that would be as far as I'll go with that one. So the derivative of that using the product rule will be 24x squared minus 20x plus 12. Okay. Questions about problem number 19? All right, number 20 is using the quotient rule to find its derivative. And here we got f of x is equal to e to the x divided by 7x squared plus 6. So the top would be my numerator, e to the x. The bottom would be the denominator, 7x squared plus 6. If the top would be e to the x, what would be its derivative? E to the x. The bottom is 7x squared plus 6. What would be its derivative? 14x. So now f prime of x is this. The bottom times the derivative of the top. That's the 7x squared plus 6 times the derivative of the top, which is e to the x, minus the top times the derivative of the bottom. The top is e to the x, the bottom is 14x. All that's divided by the square of the bottom. Okay. Now let's do this. It's probably easier to factor out something here. What can I factor out in the numerator? Let's factor out the e to the x. If I factor out the e to the x in that first term, I'm left with 7x squared plus 6 minus, factor out the e to the x out in that second, it'll be 14x divided by 7x plus 6 quantity squared. And I'll just rearrange some terms here. So have the e to the x on the outside. The inside, I'll write this in descending powers. 7x squared minus 14x plus 6. Whole thing divided by 7x plus 6 quantity squared. And it would be best if I brought that up. Are there any questions about problem number 20? And finally, problem number 21. Does everyone have this? Okay. Okay. And then problem number 21 has 3 parts to it, where The total sales of S in thousands of DVDs of a certain movie are given by the following formula. S is equal to 70t squared divided by t squared plus 100, where t is the number of months since the release of the DVD. Use the formula to answer the following questions. So in part A, they want S prime of t. So let's start with that. Here we got S of t is equal to 70t squared divided by t squared plus 100. And in this case, S prime of t. Well, I know the top would be 70t squared, and the bottom is t squared plus 100. Well, if the top is 70t squared, what would be the derivative of the top? 140t. And if the bottom is t squared plus 100, what's the derivative of that bottom? 2t. All right, so using the quotient rule, it'll be the bottom times the derivative of the top. It'll be t squared plus 100 times the derivative of the top, that's 140t, minus the top, 70t squared, times the derivative of the bottom, 2t, divided by the square of the bottom. That's t squared plus 100, quantity squared. And then we just do a little bit of algebra here. 140t times t squared will be, okay, yeah, 140t cubed, plus 140t times 100, that's going to be, no, that's 14,000 t, minus, let's see, 70 times 2 is 140, and t squared times t is t cubed. That whole thing will be divided by t squared plus 100, quantity squared. Well, this is going to be simple because 140t cubed minus 140t cubed, that's 0. So I will end up with 14,000t divided by the quantity t squared plus 100 squared. That's S prime of t. So that was part A right there. In part B, they want you to find S of 20 to 2 decimal places and S prime of 20 also to 2 decimal places. Well, we start with the original. For S of 20, we use the original function S of t and just substitute the t's with 20. So this will be 70 times 20, and that's squared, divided by, the t is 20, so it'll be 20 squared plus 100. I'm going to do the numerator first. That'll be 70 times 20 squared. That's going to be 28,000. Okay. 70 times 20 squared, that's 28,000. Divided by 20 squared plus 100. That'd be 500. So 28. That's right. 28,000 divided by 500. That's 56. Okay. And then S prime of 20, we use the S prime of t, which is 14,000 t divided by t squared minus plus 100, quantity squared. So it'll be 14,000 times t, which is 20, divided by 20 squared plus 100, and all of that would be squared. Let's see here. 14,000 times 20 That's 280,000. The denominator is going to be this. So I'm going to do left parentheses 20, and that's squared, plus 100, then close parentheses, and then I'm going to square it. That's going to be 250,000. So 28,000 divided by 280,000 divided by 250,000. That's going to be 1.12. Okay. Now, what do these values mean? That's what Part C is asking for. What do the values indicate? Okay, so here's what those two values mean for S of 20 and S prime of 20. That means this: after 20 months, because our T is a time in months, the total sales are this. If you take 56 multiplied by 1,000, because the problem does say that your total sales is going to be in thousands, so we must take 56 multiplied by 1,000 to get 56,000. And the sales are, and here, this is where we use that rate of change here. And it's positive, so that means that it is increasing at a rate of, and this has to be multiplied by 1,000 as well, so 1.12 times 1,000 would be
120. Or
11,200. So it'd be 11,200 DVDs per month. Huh? Well, in the problem it does say in thousands of DVDs, so we have to multiply by 1,000.
Would 1.12
Here's-
times 1,000 be 1,120?
Mm-mm. Oh, 1,120. Where'd I get that from? You're right. Can be going that far, that fast. So it'd be 1,120 DVDs per month. And that 56,000 means DVDs as well. So let me change that. Okay. All right. Any question about problem number 21? Or are there any questions about what you will see on your second exam on Monday? Okay. So Monday is just your exam. And then next Wednesday, we'll get back into chapter 3. And in chapter 3, we'll start with implicit differentiation.